Hello students, welcome to the session. Today's topic for the session is irrational numbers. So we will discuss about their definition and we will do some questions related to your irrational numbers concept. Okay, so let's start the session. So first of all, we should understand what this irrational number means. See this expression, this root 2 type, root 3, root 5, root 7, they are irrational numbers. Why? See square root of they are what non-perfect square. They are what non-perfect square. So square root of a non-perfect square are called irrational numbers. See, if I write 25, but 25 is my perfect square number, 5 square. So square gets cancelled. So this is 5. But what about 35? This is non-perfect square. My 35 is a non-perfect square number. This is your non-perfect square number. So therefore, this is your irrational number. Okay. So basically, irrational numbers are those which are not rational. Clear? Irrational numbers are those which are not rational. Also, we have discussed their decimal expansion. So irrational numbers has their decimal expansion as they have their decimal expansion as non-terminating, non-terminating and non-repeating. Non-repeating is your irrational number. Clear? So irrational numbers are categorized as non-terminating and non-repeating. That means, see, if you have a decimal expansion as 3.1415925, that is your pi value. This is your irrational. So non-terminating, there is no end of this decimal after a decimal place, and also numbers are not repeating. Numbers are not repeating, or there is a no fixed pattern which is coming after some time. Okay, so this is your non-terminating and non-repeating case. Similarly, root 3 value is 1.73205080. So by the decimal expansion also we can identify the number will be your rational or irrational. So if they have given only this side, this decimal expression, if they ask you, tell me whether this is a rational number expansion or irrational number decimal expansion. So it is your irrational number decimal expansion. Why? Because after the decimal it is non-repeating and also non-terminating. Clear? Similarly, root 2 has also value 1.414213 213 and so on. So after the decimal, it is repeating, it is non-repeating and non-terminating. Okay, so by decimal expansion, we can also identify whether your number is rational or irrational. Okay, so in both way, we can identify. So let's do a numerical to show 1 by root 2 is irrational number. Okay, we have to show this. Yes, we have to show this. So 1 by root 2 is an irrational number. We have to prove this. Okay. So let us assume that. So always these type of proof are solved by contradiction. Always let, yes, this is your rational number, but after some time you will get some contradiction and we will say that our supposition or assumption is wrong. So it is your whatever they are asking. So let us assume the given 1 by root 2 is a rational number. So it is your rational number, whatever they are given. So 1 by root 2 can be written as a by b form. Okay. So if it is a rational number, okay, if it is your rational number, it will be expressed as a by b form, where b is your non-zero, a comma b integers. Okay. A and b are integers and no common factor other than 1. Okay, they have no common factor because they are in the simplest form. So no common factor other than 1. So if we cross multiply it, it will be written as b is equals to root 2 a, and if I bring this a to the left side here, so b by a will be written as root 2. Clear? So b by a will be written as root 2. And since we know that b and a are integers, okay, so your b is integer, your a is also integer. So then b by a will be your fraction, na? Fraction or rational number. So let us suppose if you have 2 as a integer and 3 as an integer. So if I write 2 by 3, so this is your rational number, fraction. Okay, fraction. So your left side is becoming a rational number. Okay, so that means your left side is equals to right side. If your left side is your rational number, then automatically your right side will also be your rational number. Clear? But we know that root 2 is an irrational number. We know, but there is a contradiction here. But we know that root 2 is irrational number. So that means what we have assumed in the first step is wrong. So our assumption is wrong. So this is a contradiction. So this is your contradiction. That means our supposition is wrong. So this is a contradiction. So our supposition is wrong. Therefore, your 1 by root 2 is an irrational number. Okay. So they have many properties. Sum of irrational number is also irrational. Subtraction is also irrational. Okay. So there is vast application of a irrational numbers. So for this session, this is your topic. Till here, revise. And if you have any doubt, you can contact me through my Urban Pro profile app. Till then, revise. And let's meet in the next session. Thank you.